Hamann.
Okay.
Welcome on stage.
Thanks a lot. So also welcome from my side. Very happy to be here. I'm perhaps working on topics which are a little bit lower on the things that you're interested in, even what we heard before from Bert. But it's also, we try also to help you build better intelligent systems. So I'm more interested in the plumbing, so the framework that I can use to build my system on top. Also, real-time plays an important role. It bears a very fancy name, the Cyber-Physical Metaverse, and I will explain to you what we mean with that, why it's important for us, for the world, and will help us to build better systems, and why we are also interested at Bosch in working at that. So I'm working in the Bosch Research Center in the proximity of Stuttgart. Okay, let's go into the agenda. I mean, of course, the title contains the word metaverse, so I will need to talk very briefly what's the metaverse. That's the basic of what we are talking about today. But I will then quickly add another term into it, a class of systems called cyber-physical systems. So cyber-physical systems are basically systems containing physical but also computational aspects, and they use sensors to monitor physical processes, and they use actuators to take control over these processes and control them. So that's a class of system which is very important for Bosch, because everything that we produce, that we develop, is basically a cyber-physical system. So you might take a car as an example and all its subsystems. So engine control. You control a combustion engine or an electrical engine. That's a cyber-physical system. The braking system, the steering system. Also the things that you have at home, so a dishwasher is also a cyber-physical system, or a hammer drill. So you see a lot of things that we have in our world are cyber-physical systems, and that's basically the DNA of Bosch, building these cyber-physical systems. And you have seen now perhaps that it has changed from metaverse to industrial metaverse. That's something which is also already quite under discussion in industries which are heavily producing. So we will go into that. But then we will come into the cyber-physical metaverse. And for this, we need something additional. We call this reliable distributed systems. So I will dig into what we mean with that. And if we bring everything together, then we arrive at what we call the cyber-physical metaverse. And I will give you some examples what we intend to do with it and why it helps us building better intelligent systems. Okay, let's start at the basics. We are living in a connected world, very clear. We interact with devices and with other people, usually through our smartphones, and we exchange data. I mean, that's very clear. This has now been, or this connected world is augmented with the metaverse. It's not new. Some of you might remember Second Life many years ago. This was already a start. But it's basically creating a virtual world in a computer environment where people can interact with each other. And usually our entrance to this world is XR technology, so virtual reality, augmented reality. That's how we then take part in this world. And what then we can do, we can visit, for example, a virtual location where we are not currently present at. This might be one of our buildings at the research campus of Bosch. Very clear. If we look at use cases that are realized on VR, it's usually virtual job fairs or even conferences. I mean, during Corona, we participated. Some of you, perhaps not in VR, I don't know if this was already happening then. But in principle, you could participate in job fairs and conferences virtually. You could do virtual work. That's what Apple, at least, is now also envisioning with the VR headset they are bringing onto the market. You could do training, remote guidance, repairing a complex machine by the help of a remote expert that guides you through the different steps. Gaming is a big use case for modern consoles. And some companies also want you to click on ads in this virtual world and show ads to you. I mean, of course, that's... is this really enough? Is this really something that is a game changer? I mean, that's nice. It brings some value, it brings fun, and it helps us in productivity reasons. But if we want to take a further step, we need an additional concept. And so I'm aware that digital twin is a buzzword which has a lot of meanings. And it's because it's also so diverse. A digital world, a digital twin is a representation of a thing that exists in the physical world, and it has kind of very different, let's say, flavors. It can be just static data that you collect. So you just collect data, for example, in a production process about a certain step in the production step, for example, welding. You can also use 3D models that you're able to simulate. Then you could do something like a virtual fast forward, try to understand, okay, how's my object going to behave in a few seconds, and then might try to take some decisions based on that. Or you can just look at live operational data and see what's happening, monitoring what's going on. There are examples for this, very prominently, of course, the NVIDIA Omniverse. Renault Group also launched something end of last year, and use cases for those production-heavy industries is virtual production staging of production lines. You want to monitor and improve the performance of your assets, or you might also try to do something like predictive maintenance, try to find out when is a certain component going to fail, and to predict it about it to reduce downtimes. So that's usually what happens in these industrial metaverse use cases. If you now extend this image that I have here, the schema, and we add now this machine digital twins inside, then we have, let's say, a new connection between the real world on the left side and the virtual world on the right side. Now we stream data basically from the real world into the virtual world. There we can do then some analysis, some simulation, we can use machine learning, and we deliver back knowledge, insights, and then a human operator can act on it, can take some decisions. But I think it's very important to mention that what's not happening, so the digital twin, the virtual world, is never taking control over a physical object in the real world. It's a one-way route of basically sending information into the cloud, let's say, in the industrial metaverse, and then we get insights, but we don't take control from the virtual world in the real world. And now you might already, let's say, have an idea what I'm going to talk about now, what's then the logical next step. So I think that's also not everything which is possible, where we could create benefits. So the next step, we need another concept, and we call this an actionable digital twin. Again, this buzzword digital twin, but this actionable is an important extension. It's an important extension. So now, basically, this twin also contains APIs that manipulate its physical twin in the real world. You can see it's a new kind, or the next step of an API, not just for a programming language or having a toolbox where you have an API, but you have really an API for a physical device. And then at Hyundai, you can read about the meta-mobility universe, where they think about proxy experience using mobile robotics. That's one example. That's, of course, not the example which is, let's say, the most interesting from Bosch perspective. And that's why I'm using now a different example to guide you through the rest of the talk. It's infrastructure-based driving. And here it's very important, we really mean base driving. We don't mean infrastructure-assisted driving. It's really basing the automated driving from the infrastructure. And then you can use this actionable digital twin to create something that we call a function digital twin, which doesn't have a representation in the real world. It's rather a higher level service that takes control over physical devices, for instance, your car, and helps you, for instance, to cross a very complex situation, a very complex crossroad. And this could be a service offered to you as an owner of a car which is empowered by such, let's say, actionable digital twins, or that can, of course, play along with these functional digital twins. Okay, now if we extend now again this image, now we get this function digital twin inside. And now something changes. Now you see the first time reliable distributed systems. Until now, the use cases I've talked to you about, they're all based on best effort technologies. So there can be latency. So we're not talking about real-time properties. We're not, if some data get lost, of course, then it's a pity, but it's not a deal breaker for these use cases. If you are doing gaming in VR and there's latency, you have a less good experience, but nobody's going to die. If we now use this function digital twin and we take control from the infrastructure over a car, we need to make this linkage between the virtual and the real world reliable. And this is what we call RDS, reliable distributed systems. And there we need defined qualities. So we need safety, we need security, and we need real time. And these are all properties which are inherent to these cyber-physical systems that I've started the talk with. Okay, let's talk now about reliable distributed systems. So that's what we need to take the industrial metaverse to this next step to arrive finally at the cyber-physical metaverse. We all know distributed systems, most prominently the cloud. And this has changed a lot business models and value streams already in the past. I mean, look at video streaming, music streaming. I mean, I still have a DVD player, but somewhere in the cellar, so I'm not using it. I'm streaming videos. I'm also streaming music from various, let's say, streaming services. So this has already shifted a lot of how value is created, how things are let's say, how systems are constructed. But cyber-physical systems have still been protected because we were missing these R's, this reliable part. So these technologies, they are not real-time, they are not made for safety-critical systems, and also you might know that there are also quite some security issues as soon as you go distributed. And this protected until now, let's say, this class of cyber-physical systems to be cloudified. And of course, I mean, now imagine this, let's say, automated driving function or infrastructure-based driving functionality. You wouldn't use it if you cannot be sure that it's safe and that it's reliable and that it's real-time, right? So we need to talk about how can we make this happen. And you might also have doubts about it. Oh, this will never happen. We cannot make all these things reliable. But actually, we already did it at Bosch. So there's a system that has been commercialized that you can buy now. At Bosch, it's called automated valet parking. And that's a functionality which automatically parks your car in a parking garage. For example, at the Stuttgart airport, one of the parking garages is already equipped with this system. So you can leave your car and it parks automatically. And in the presence of other cars, which are not automated, and also in the presence of humans walking around. So it's a completely safe system where the intelligence has gone out of the car into the infrastructure. And of course, now this is a controlled environment, so we own the servers in the garage. We also own the communication infrastructure. And so there's definitely a challenge bringing this to the public space, but it's not a technical challenge. It's more a challenge about how do we bring together all the different players. And let's talk a little bit about this now. Because nobody can buy this, can build such an RDS system in the public space alone. So you need the hyperscalers who have the ubiquitous compute, which is available everywhere. You need the telcos that connect your mobile devices to this compute. You need, of course, the OEMs building the system, so the car manufacturers, for instance, if you talk about infrastructure-based driving, so Volkswagen and Mercedes as two examples. But there are also other domains, also industrial automation. You also have the same trend in industrial automation that you want to put functionality away from the machines into edge computing settings. So that's why you also Siemens and Rexroth, which is a Bosch company, are very much interested in such a technology. And then, of course, you need players like Bosch, which are the champions of building cyber-physical systems who know how to make real-time, safe, and secure systems. And that's why we think at Bosch, if we now rearrange this in a stack view, that these competencies that we have are in the center of how we need to build such an RDS system. And where all players play together and we make it safe, secure, and real time. And there are already, if you now go down the stack upwards, there are already a lot of things happening. I mean, let's start with wireless communication, because that might be the most present, because you hear it all the time. People talk about 5G, 6G, where you have specific ultra reliable, low latency communication flavors that give you very low latencies and guarantees. We are seeing that also globally the telcos are working together in an initiative called Camara, where they're defining network APIs. So APIs from an application where you can an application can ask quality of demand. So a certain quality of service basically to this wireless communication. We see it on the hardware vendors, so the hardware platform. Companies like Intel give you also more control over how resources are assigned in these complex compute platforms that we have. One example is this Intel resource-directed technology. And we also see telcos coupling very tightly edge computing into their core networks so that you don't have to break out into the internet to do some compute. And this is often also done with one of these traditional cloud providers that then have instances, for example, in the core network of British Telecom. Okay, if we want to, we also need to free the software from the cyber-physical system, so we need virtualization. And virtualization, we know virtualization, virtual machine, containers from classical IT world. They struggle a lot with real-time and bounded latencies. Containers need to spin up several seconds to do anything. So that's not suitable if we want to have CPS functionality in the cloud. That's why we're looking at Bosch into bytecode sandboxes. One very prominent example of this is WebAssembly, very upcoming technology. You should, if you haven't taken a look at it, you should. It's going to find its way into, oh, there's something happening. Finding its way into many systems. And at Bosch, we are working on a framework which is called Silverline, where we use WebAssembly, currently mostly in industrial automation, to really flexibilize the way how we can deploy software from small devices, microcontrollers, up to data centers without a technology breach in between. If you look now on the software platform, you need, of course, interoperability. There's this Metaverse Standard Forum, where also now also the telcos, which are organized in the 3GPP global initiative, are also looking into how to participate, so how we can standardize the concepts, the data that we need in the metaverse. On the right side, associations like Etsy are doing, let's say, more domain-specific standardization, standardizing messages that exchange between autonomous cars, so CAM messages, corporate awareness messages, what is my speed, what is my direction, CPM, collective perception messages, so what is my perception about others that I share then also with others. So this is really about providing all the information that you can use reliably on top when you build an RDS application. Okay. I told you, I think that we can build better intelligent systems with this kind of technology. And there are some examples. I mean, on the right side, you see basically, you know that deep learning pipelines still have a hard time to distinguish even a red, a yellow, and a green light. So there's often, I mean, we saw it recently, there was a video from Elon Musk driving in his Tesla, and exactly he stopped at a traffic light, it was red, and the car started to drive. It just happens. So it would be much better if we had reliable information from the infrastructure, let's say from the traffic light itself, that we can rely on, that we can use to take decisions. It would be much more robust. Same for road conditions. If we have to find it out while we are driving on the road over the ESP system that it's slippery, that might be too late. That's not the best way to build the system. And on the left side, let's say taking this bird's eye view. I mean, currently everybody wants to build all the OEMs want to build an autonomous car by having all the sensors on board. But obviously this has some shortcomings. I mean, if you have parked cars and a kid is running behind one of these parked cars, you have no chance to see it outside from the ego perspective of your car. But if you can use reliably information from the infrastructure, that's very easy to detect and very easy to react on. And exactly, if we have the Cyber-Physical Metaverse backed up by RDS, we can have all these use cases possible. Okay, it spans multiple domains. I talked a little about mobility because I think that's for the general public not looking into, let's say, other domains like manufacturing or building technology is the best example to understand this, but there's, let's say, similar motivations and similar use cases also in manufacturing. Let's say, freeing, let's say, these closed control loops, which are now on very stale hardware running very close to the machines, also putting them to edge centers into the cloud, or building technology, which are both also very important domains at Bosch. Okay, so the conclusion. The cloud and XR basically enable the mainstream metaverse. If we have RDS, we can reliably link the physical and the virtual worlds. And this will basically enable the cyber-physical metaverse, which in my opinion has far more possibilities compared to what we are currently exploiting. And it will help you build, of course, better intelligent systems, because then you can use all your applications, all your ideas, even the toolbox that Bert told us, with high compute resources somewhere in the cloud and reliably use the information provided. And it's, of course, full of business opportunities. That's why I'm working on it. That's why Bosch is working on it. And first application, my prediction, you will see it very soon in a few years. You will have first infrastructure-based functionalities. And really the last slide, so the cyber-physical metaverse is for cyber-physical systems, what the cloud has been for IT. So so that means it's a game changer. We will see it. We will see new kind of application emerge. Okay, thank you. Questions?
Arne Hamann.